ID is 1, 2, 3, 4, all this, right? So, okay. So coming back to the what has been mentioned earlier on. So what you need to do is analyze. Okay, you put analyze and then you go to classify, right? Then sorry, what I'm saying. We haven't select. Sorry, yeah. Data select cases first. Data select cases. Now, first we go to random sample. Okay, I go on exactly. You follow, yeah? Exactly 60 from cases 100. From the 100 cases. Everyone? Are you with me?
Yes.
Okay, then you say continue. When you say continue, then you say okay. What's gonna happen is you will have, can you see this, all this? This is the one that has been selected.
我终于可以睡觉了。我甚至为他贴心的开了个小灯。
So let's try and check whether you get it correctly. Now, can you go on analyze, because you cannot see the screen. So, but you can see my cursor, right? Can you see the movement of my cursor? Okay, then you click analyze. Okay, then you go to descriptive frequency. Okay, just use one. You just put ID across. Then you see whether you have. Then you get 60 observations. Is that right? Correct, isn't it? Okay. Now, every one of you will have 60 observations, and like I said, because it is random, so you may not get the same one that your neighbors, yeah. So this is the one that you get. So if you want to keep this data, so that, remember I told you when you do random, if you don't save it, you want to run again random, then you will get a different set. So you have to be careful with this. Okay, even in the exam.
你有没有印象？就昨天那个花裙子。
昨天
你上02有个花裙子，第6袋子那个。最后跟老头说什么？他们组就2个人作业。那个花裙子就是都有这样聊的那个女的其中一个。啊。那个花裙子就是万幸仪。因为我关注着，我跟他互关着这个小红书，我看他小红书在那发内容的，就是那个花裙子。
Okay, now let's go back to what the question.
对，那个花裙子昨天大包小包那个就是都有在聊的一个。
Okay, now I want to check again. So if I were to.
那确实豆子现在也配不上。那个也挺也看着也还行的，反正。
The one earlier. So let's try data, select cases. Okay. So here we are talking about range. Okay. So the range will say select cases, range observation 1. Is that the question, Nabila? You asked that question, isn't it?
Yes.
Then if you choose, let's say for example, you want to ask, you asked me just now, what's the difference between the first way of doing the selection versus doing this range, yeah? So let's see what happened. If you say first case 1, it has to be first 60 lah, last number 60 lah, like that, isn't it? Okay. So then when you say continue, okay, what happened is when you look at the data again, you can see that it will take cases number 1 to number 60.
So instead of random, so they just select.
You will select that one. Yeah. So but
outcome will be different, right?
Pardon?
Instead of outcome, then you want to see the outcome, then you run the distance.
Yes, it will be different. It will be different.
So okay. The question will be asking, you mentioned, you will specify like randomly selected the center for us to choose the center, right? Just in case, because I got confused when, as you mentioned just now, select the 60. My first thought, I just chose from the series of 1 to 60. That's why I selected that. But by right, it should be randomly selected 1 to 60.
Okay.
Over 100.
Okay. So let's do this. I'm gonna close my output here. Now, because we just want to check whether how different is it gonna be, right? So everyone, so what we do is, can we just try first do 1 to 60? Okay, like I showed you here. So meaning that if you were to be doing this, so select cases here. So in order for you to work on this, okay, I think the best thing for you to do is just say delete. Okay, meaning that it will give you only those that you want to work on, like this. Did you get this? You say delete. Okay, everyone. So I'm using we are using the range. Okay, now in order to make sure that this thing is not going to be, your original is not going to be destroyed, you just say save as. Why don't we give it like HPAT discriminant, say DISC, I don't know, just to indicate first to 60. Okay, so then you say save. Alright. Okay, now let's work on this using the discriminant analysis. Now what do? We go on analyze, right? Analyze, we go classify, then we go on discriminant. Okay, you can see this instruction, you can see, right? The one that you can see will be the output. Okay, alright. So what do we put as the dependent variables? Region, right? You bring region to the other side, and then you define region. It's asking you minimum and maximum value, which is 0 and 1, right? So you just say continue. Okay, what will be the variables that we need? It's starting from x6, isn't it? So we can bring everything x6, x7 up to x18. Up to x18, yeah? You bring it over. Okay? Then we can use stepwise method. So for the stepwise method, okay, we use stepwise method, right? Then go to statistics. You have to listen. I think all this instruction I showed you during the Hepto demo. Since now we are not we are on virtual, so you have to use stepwise method. You go to statistics, isn't it? Then you click on descriptive, will be the univariate ANOVA. Then you say box M. Then on the function coefficient, you go on the unstandardized. Okay, then we can actually go on the within group correlation. Okay, so I repeat, on the discriminant analysis statistics, you click on univariate ANOVA. You can put on box M. Function coefficient will be the unstandardized, and then we go on the correlations. Okay, then we say continue. Alright, click on the methods. Since we are going to use the Mahalanobis distance, can you click on that? Because the default say is with lambda. Can you change that to Mahalanobis distance? Guys? No?
Can.
Okay, then continue. Continue, yes? Then that is under method. If you look under classify, okay, for the classify, you go on the case-wise results, yeah, the case results you put under leave one out classification. Because if you were to click on this, then you can click on both, but you have to choose with the summary table or leave one classification. You can click on this thing if you want.
So the person is click only one out classification.
You want to leave one out classification. I mean, just for the sake of really checking what will appear, you can click also on the summary table, see what it is. Sometimes, okay? Then you say continue. That is under classifier. So here, let's see saved. I think at this point you don't have to worry about saved because we are not doing anything for that. Okay. Then we say okay.
Doctor, could you share the screen of your output?
Yeah. I'm just looking here. I just want to check whether I'm doing 7, 8. We start with 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, right?
Correct.
Yeah, okay, let me see. I'm just checking my results first.
Okay.
Okay, now I'm gonna share. Alright, so I stopped sharing just now. Okay, where is the output? Okay, can you see the output?
Yes, doctor.
Okay, let's see whether is it almost the same as what. So you have the two things. The US one is code 0 and outside US is code 1. Okay, did you get the same thing as what I have here? Yes?
Yes.
Test of the equality of the group means 6 up to 18, and then the width lambda. Okay, and the F and all this. Same, yes?
Yes.
Okay, the box M. And then significant 0.085. So it looks a bit 0.085, yeah. Okay, so this is variables entered. You have 17, 13, 11. In addition, we have 12 and 7. Did you get the same one?
Same, doctor.
Yes.
Okay. So this is using this way. Then this is the variables in the analysis. So not in the analysis, just the way, it's just the same how to, in terms of the process, you can check the one that I use with the Linux Lambda. So then you have the summary of the canonical discriminant function. In this case, the canonical correlation is 0.798, right? Okay. Now, let's get your calculator and compute the, you take 0.798, you multiply by 2. What did you get? What did you get? 0.798? This one. Summary of the canonical discriminant function. what's the value? So what's the value? I'm holding my calculator here. So we get 0.798, right? You multiply by 0.798. So you get something like 63.6, right? You get 63.6, guys?
Yeah.
Which means that about 64% of the variance is explained by here instead of three variables we have like 1, 2, 3, 4, 5, right? Okay, in terms of the variance, the canonical square is still about 64% like what we had for the examples, right? This is the example says about the example says about 56%. Here is 64 because we have more. And then here you take that and minus this, you get 3.62. So this is the standardized canonical functions. Okay, so we have all these. Then you have the structure matrix. So X7. This is weird, isn't it? X7 in terms of the structure matrix, loading is not that high. Something is going on here. E-commerce. So the e-commerce here. So X11, 13, 17 still. X17 is the highest. 13 is the second one, and then you have your product line. So the rest of it is not very high. This is using, then in terms of the classification, about 93.3%. All the centroids. So you can actually save this and recheck. Okay, so that is if you were to choose the first 60. Okay. Now let's repeat this whole process. Okay, rather than choose the first 60, now I'm going to go back to my original data, which is the one with 100. So I advise you to do the same. Go back to your original data, everyone. So you get back your original data. Okay, so I'm gonna share again. Okay, so this is the original data. Okay, so can you see that this is 1, 2, 3 up to 100? Okay, so I go back to the original data. Everyone with me, or some of you may just disappear already, not in the room. So okay, okay, now let's start selecting again data. Select cases. We go if random sample. Go random sample of cases. So exactly 60. Exactly 60 from 100. Okay, exactly 60 cases from the first 100 cases. Then we say continue. Okay, So now we say okay. So if we were to do that, okay, can you see the one that is being crossed? See or not? Okay, then it's slightly different, isn't it? Earlier on, what we did is we asked the computer to say, okay, I want number 1 to 60. So that is what the results that we get here. You say you want 60 out of the 100 cases, randomly select. Okay, if you were to be doing your own selection, just compare with mine. Do you get the same one? Nabila? She's Nabila and okay. Did you get the same one? Different. And you get the same one?
Also different.
Different. So I'm gonna call names now. Who else? Wanru? You get the same one? Hello, open your
No,
screen.
yeah.
The
Oh,
same?
I select the first 60, so I got the same.
No, now we repeat. We don't want to use the first 60.
Oh, okay.
I mentioned earlier, we want you go back to your original data.
Okay, I select it now.
Then you say select random.
Okay.
Select random 60 out of 100 and see whether yours is the same as what I have. What about the rest? When you Zinrai,
Different.
also different, right?
Yeah.
So this is what who is this triple N? Okay, it's okay. Nabila, is it triple N?
Yes.
Okay, sorry. I see a cat there. Is it the cat? Okay, so which means that, okay, if you were the way you select your sample, okay, then you will get different. So when you get different, which means that when you talk about random, definitely it's different, right? So when you say different, so what happened is you run your analysis, then whatever you get in terms of your canonical correlation and all that will be different. Okay? Now, so let's work on your data, and I'm working on my data. So I'm gonna do this and say go back to my select, yeah, select cases. Then I want to work on this thing. Okay, before that, let's check whether you really have 60. There's always need to check. Use the ID and check. I check mine. Okay, mine I have exactly 60. Okay, now we want to go back and say data, select cases. Then we go on delete. We delete, yeah. So when you delete, then this is what's gonna happen. You can see that in terms of the ID, it just select. So I have exactly 60. So when you delete, did you get this? Got 60 cases, right?
Yes.
Okay, now my advice to you is save first. You say just now we save for 60, yeah. So now save this. Just now we paste my name is HBAT this 1 to 60. Now I'm going to use this. Okay, I will just say this one discriminant random 60 out of 100. Just I give the name out of 100. Because if I don't save this, I were to do it again, then let's say I'm running it and I go back and then I just want to try it again, then I will have different results. Then you panic, you say, oh, something is wrong. Okay, now let's work on this and do the and classify discriminant like what we did earlier on. Then we have X4 region, define minimum 0, maximum 1, continue, and then the variables that go in will be X6, 7, 8, 9, 10, 11, 12, 13, 14, 15,